Hey, welcome to your first instructional video for this Math 256 course. We're going to go back to the very beginning to place value. Why are there dogs and pizza and things on here? Well, you'll find out. But we're going to go back to place value, and I need you to understand something. I need you to do two things as you engage in this video. Number one, engage in the video. I hope you have paper and pencil handy, and you'll see as I go through this, I'm going to ask you to pause the video and do something before you continue the video to see what I'm trying to get at. Second thing I want you to be aware of is I need to put you in the seat of a young learner who's learning about numbers for the first time. It might be uncomfortable, but it's really important that you kind of get, even if it's not exactly the same, you kind of get a little bit of a sense of what it's like to be, let's say, a preschooler, kindergartner who's learning about the world around them for the very first time in their young life. And when we talk about mathematics specifically and the use of numbers as a representation for quantities, and ultimately we build up the idea of place value over time, you need to feel it, to feel what that's like and what the learning process will look like. And it starts out with just this. Have you ever thought about what is 2? Is that symbol a 2? Well, what if we did Roman numerals? Is that symbol a 2? I will argue that neither one of these is 2. They're just representations for the idea of 2. And 2 is an idea. It's a quantity that in the course of history, there became a need for human beings to communicate a quantity, an amount of animals that they saw, or of trees that they saw, or plants that they had, or who knows, or people that they saw. How many were there? And communication, as it became in written form, there was different ways. And in fact, in different languages, there's different ways. So just that symbol of 2 is not by itself a 2. It's just a representation for the idea of 2. And if you were in Japan, you would have different representations for the number 2, and you would say it differently as well. Or if you're in an ancient Babylonian culture, your idea of 2, and by the way, the ancient Babylonians didn't even use base 10. They used base 60. Yeah, they had 0 through 59, so 60 different symbols to represent the numbers that they needed. Whoa, can you imagine? But for us here today, we're going to go back to the beginning, and just to justify a little bit more about why I'm going to take you through this, we're going to look at a little bit of a teaching model. And so here's how I think. And if I could simplify teaching down, it would flow like a pyramid with a bottom layer, and you build on the next layer, you build on the next layer, you build on the next layer, etc. And so the bottom layer is meaning and purpose. We try to provide through our teaching, the audience feels that there's meaning attached to it and there's a purpose for learning what I'm learning. And then learning happens through problem solving. Learning doesn't happen through mimicking. Mimicking is what you do when somebody shows you how to do something and you just mimic the procedure, perhaps with different numbers, but a lot of times void of any understanding for why you're doing what you're doing. But we're going to engage with meaning and purpose through a problem solving process in order to develop concepts, develop ideas, develop ways of thinking about the mathematics. And then all of that flows to the top where we get to facts and skills. I mean, ultimately, if you think about our elementary education, we want kids to come in K and leave 12 with some facts and skills that they're fluent in. And we're going to be talking about fluency a lot in the future, but I just wanted to drop that word now because that's our aim. And it's my belief that this fluency to be able to engage in mathematical thought in all kinds of areas and levels of mathematics works like this. Students learn meaning and purpose to build a foundation. They engage in problem solving, thinking, productive struggle. They attain conceptual understanding. At that stage, it may not be real fluent or efficient, but it's conceptually understood. And then you build on that ultimately to the facts and skills that we want students to learn. Now, that's what I believe is a good way, just a simple teaching model. But the reality is, math education, and probably a lot of education, builds like this. You learn some facts and skills, you mimic, and then you learn some more facts and skills, and you learn some more facts and skills, and you just keep learning facts and skills. And none of it is built in a way that is going to become a long-term memorable situation where students can use what they've learned outside of that classroom setting. Now, that may just made a bold claim there that we may be able to debate or discuss, but as you go through this course, you'll hear more and more and more about that. But we're going to engage in just one more minute in a learning process where there's, I hope you see meaning and purpose. I hope you engage in a problem-solving process that involves some productive struggle to attain concepts which will ultimately take you to these facts and skills that we desire. Are you ready? Paper and pencil in hand. I'm going to share some things and then I'll ask you to pause and engage. Let's get to work.